number 11 is saying a function defined by f of x is equals to 4 over x to the power 3 minus 3 over x plus 2 for x not being equal to 0, and the graph of y equals f of x is shown in the diagram. Find the set of values for which f of x is decreasing, right? And for that we need to consider differentiation, right? Since differentiation will give us f prior of x, right, which is the first derivative. And if we can get this is equals to 0, we get the turning points, which is this point and this point. And as you can see, for a decreasing function, we need parts where the graph is slanting towards the left, and that's this part and this part. So we need these two values to determine the set of values of x, right? Because we can see that it's only at this part and this part where the graph is slanting to the left. So whenever we have a graph where a line slanting to the left, it is decreasing, and when we have it slanting to the right, it will be increasing. So what we need to find here first is the first derivative, right? And we can rewrite this f of x in this form. F of x is equals to 4x to the power minus 3 minus 3x to the power minus 1 plus 2. So the first derivative will be minus 12x to the power minus 4 plus 3x to the power minus 2, right? That's differentiating. We are multiplying by this power, then subtracting 1 from the power. So minus 3 times 4, that's minus 12. Then x to the power minus 4, because we subtract 1 from the power. Then we do the same for minus 3x to the power minus 1. It's minus 1 times minus 3, which gives us a positive 3. Then x to the power minus 2, since we are also subtracting what? 1 from the power, right? And for us to get the turning points, we are saying this is equals to 0. So 0 is equals to minus 12 over x to the power 4 plus 3 over x squared. Right? That will give us 12 over x to the power 4 is equals to 3 over x squared. And cross multiplying, we get 12x squared equals 3x to the power 4. And if we divide by 3x squared both sides, we get x squared equals 4. So if x squared is equals to 4, for us to get x, we are square rooting both sides. So x is equals to plus or minus 2, meaning that the x value for the turning point here is 2, and for this part it's minus 2. So we can see that going from minus 2 through to 2, we have these parts of the curve slanting towards the left. So we can say the function f of x is decreasing from x equals minus 2 to x is equals to 2. So this is the set of values that we're going to consider, right? Since we have two parts of the curve which is slanting to the left, and those are at minus 2 and 2, right? And that will be it for 11 part A. So part B now says a triangle bound by the y-axis, the normal to the curve at the point where x is 1, and the tangent to the curve at the point where x is equals to minus 1. Find the area of the triangle give your answer correct to 3 significant figures. Right? We are being told that at x equals to 1, which is somewhere here, there is a normal, and we have x equals minus 1, which is somewhere here, which is giving us a tangent going like this, and we want to calculate this area right here, which is bound by the y-axis, the normal, and the tangent. Right? And from part A, we know that the first derivative is minus 12 x to the power minus 4 plus 3x to the power minus 2, right? So it's minus 12 over x to the power 4 plus 3 over x squared, right? And at x is equals to 1, at x equals to 1, if we substitute x equals 1 in here, it will be 4 minus 3, which is 1 plus 2. So we get y to be 3, right? And the gradient, if we substitute in 1 here, it will be minus 12 over 1, which is minus 12, plus 3 over 1. So we get our gradient to be minus 9. But we know the gradient of the curve and the gradient of the normal, m1 times m2, is supposed to give us minus 1. Therefore, we can safely say the gradient of the normal is 1 over 9. So that if we say 1 over 9 times minus 9, we get minus 1. So equation of normal we are going to get it by saying y minus y1 is equals to mx minus x1, right? Using this point right here, 1, 3, and the gradient 1 over 9. So that will be y minus 3 is equals to 1 over 9 x minus 1, right? That will be y is equals to 1 over 9x minus 1 over 9 plus 3. And that will give us y equals 1 over 9x plus 2 and 8 over 9. So that's the equation of the normal, right? And for the tangent to the curve at the point where x is minus 1, we are going to say at x is equals to minus 1, y is equals to, so if we substitute minus 1, yeah, it will be minus 4 plus 3, that's minus 1, plus 2, which will give us 1. So our y is 1. And the gradient, we are substituting minus 1 in here, so we have the same gradient, it's minus 12 plus 3. So the gradient is minus 9. Right? And this goes down to tell us that the tangent at the point where x is minus 1 and the normal meet at 90 degrees. Since the gradient of the normal is 1 over 9 and the gradient of the tangent is minus 9. And you can see that the result is minus 1. So that tells us that the normal to the curve at the point where x is 1 and the tangent to the curve at the point where x is minus 1 meet at 90 degrees, right? I think we're going to need that information. So for the equation of the tangent, we're going to say y minus y1 is equals to mx minus x1, right? So y minus 1 is equals to minus 9x minus 1. So that will give us y equals to minus 9x, right, minus 9 plus 1. So y is equals to minus 9x minus 8. And that's the equation for the tangent. And we have to get the point where the normal and the tangent meet. So at that point we know this y is equal to this one, so we can equate the expressions following. So it's 1 over 9x plus 2 and 8 over 9 equals minus 9x plus 8. And taking minus 9x to the other side, we get 9 and 1 over 9x. And taking 2 and 8 over 9 to the other side, that will be 8. That was minus 8. Oops, it's minus 8 from this equation. So minus 8 minus 2 and 8 over 9, that will give us minus 10 and 8 over 9. So dividing both sides by 9 and 1 over 9, we get x as minus 10 and 8 over 9 divided by 9 and 1 over 9. We get minus 1 and 8 over 41. And for us to get the y value, we're going to substitute this value into this equation. So that's 1 over 9 minus 1 and 8 over 41 plus 2 and 8 over 9, and that will give us 2 and 31 over 41. So this is the point where the normal and the tangent meet. Right, so we're having a triangle like this. It's bound by the y-axis, right, y-axis, and this is the normal and this is the tangent, and they meet at minus 1, 8 over 41 and 2, 31 over 41. So we're going to need this point and this point right here. Let me just use a different color. And for this point, this is the point where the normal crosses the y-axis, which is its y-intercept. So it should be 2 and 8 over 9 is the y-coordinate. So it's 0, 2 and 8 over 9. Alright, and for this one, since it's minus 9x minus 8, y equals mx plus c, we are having 0 and minus 8. Right? And we said the two lines meet at 90 degrees. So this should be our height and this should be our base. So we're going to get the distance between these 2 points and also the distance between this point and this one. Then we say half base times height. And for us to get the distance between these 2 points, we're going to say square root of, that's 1 and 8 over 41 squared, plus we say 2 and 31 over 41 minus 2 and 8 over 9 squared. Right? And that gives us 1.202 if you punch that in our calculators. And for these points right here, we're going to say square root of minus 1 and 8 over 41 minus 0 squared plus minus 8 minus 2 and 31 over 41 squared, and that should give us square root of minus 1 and 8 over 41 squared minus 8 2 41 squared, and that gives us 10.82. And since there's a 90-degree angle there, we're going to say half base times height to get the area of the triangle. That will be half our 10.82 multiplied by 1.202, and that should give us